Welcome everyone to another quick class. In this series of 3 classes, we'll be discussing how to determine resistance of common dynamic seating components. Today we're going to start with a dynamic back, specifically the Seating Dynamics Dynamic Rocker Back Interface. So what is resistance? Well, resistance is designed to allow the client to move a certain distance and then encourage the client to return to an upright position. And this is provided in a dynamic back either through elastomers, springs, hydraulics. In Seating Dynamics case, this is through an elastomer. This resistance, again, allows the client to move, stores that energy within the dynamic component, in this case an elastomer, and then that stored energy facilitates a return to upright. Without the resistance, when the client moved back, the client wouldn't return upright at all. The back would just fall back. So the dynamic rocker back interface has 2 elastomers within its mechanism. The impact elastomer absorbs the force of the client. The second elastomer, which is called a rebound elastomer, does just that. It rebounds, it helps return the client to an upright posture. There's 4 different levels of resistance. Clear is the default, and this is the medium level of resistance. There's then one softer than that, yellow, and 2 firmer, blue and green. So there's some issues here if the resistance is not set up correctly. If the resistance is too firm, then the client may not be able to activate this dynamic back at all, or might only move for a very short distance. This is an indicator that perhaps the resistance is too firm and needs to be changed. Also, if this elastomer does not compress at all, the forces from the client, instead of being absorbed in that elastomer, might actually translate to the frame. That's what we're trying to avoid by using a dynamic component. One of the chief applications of dynamic seating is to absorb and diffuse these forces so that we avoid breakage or damage to the equipment itself. So if this elastomer is so firm for that individual that they cannot compress it, the forces could be translated through the dynamic component and still lead to damage to the frame. So it's important to make sure this can move. So what do? Well, we change to the next softest level of resistance and see if that corrects the problem. How can we tell if it's too soft? Well, if the back engages, if it starts moving posteriorly when the client is placed into a tilt, or if a backpack is placed on the back canes, then we know we need a little more resistance to keep that from happening. We only want it to move under client forces. If the client can move rearward but not readily return to upright, that tells us also that there's not enough resistance and we have to increase that. If the metal on either side, as you can see in this picture here with these blue arrows, if the metal is actually touching each other, then again the forces can translate through the dynamic component to the frame, even leading to damage to the frame. So it's very important to make sure you're not seeing these pieces of metal approaching each other too much. If they're actually touching, definitely it's time to change the elastomer, either because it's worn or because it's simply too soft for that individual client. Now keep in mind that some of our clients may not exert great forces, but may seek out a rocking motion for that sensory stimulation. In the case of clients who like to rock, a dynamic back can be very, very appropriate to provide movement. We discussed that in our clinical indicators, providing movement, quick class. But in that case, we may choose deliberately a softer elastomer to promote ease of rocking for that client. So how do we change out the resistance? Well, the elastomers can be changed in only 10 to 15 minutes. I can actually do it myself. I'm an occupational therapist, so that's saying something. They're not too difficult to change out. And we do have written instructions on the website and video instructions, which should be available in the near future. So what's our bottom line? Well, the optimal level of resistance is critical to the functioning of a dynamic back. Check if the resistance is optimal, work with the team to change it as needed. And then finally, don't forget to check those elastomers about once a year to make sure they don't need replacing. The one here on the left definitely needed replacing. You can see there's quite a bit of force that's been occurring throughout its lifetime. Replacing the elastomers allows the dynamic component to continue doing its work in protecting the frame from those forces. Thanks very much, everyone, for joining us for this quick class. If you have more questions, feel free to contact Seeing Dynamics or myself. Thanks again.